Today we're going to look at electrolytic cells. By the end of this video, you should be able to describe the chemical processes that take place within an electrolytic cell and describe the processes of electrolysis and electroplating. An electrolytic cell is one in which electrical energy is converted into chemical potential energy. This is the exact opposite of what happens in a voltaic cell, where chemical potential energy is turned into electrical energy. So an electrolytic cell uses an electric current to force a chemical reaction to take place. There are two different things that we're going to talk about that use electrolytic cells. The first one is electrolysis. Electrolysis is using electricity to split a compound into its elements. So in an electrolytic cell, unlike a voltaic cell, I have one container that contains everything of my cell. It's not separated into two like the voltaic cell is. Also, the electrolytic cell must have a battery. The battery is going to provide the electrical energy that's needed in order to make this reaction take place. One thing that you need to know about batteries is that electrons always come out the negative side of the battery, and they flow into the positive side of the battery. So electrons are flowing out the negative side of the battery, and they're building up on this piece of metal here. So if there's extra electrons here, this entire thing becomes negatively charged. Electrons are flowing into the positive end of the battery, which means electrons are getting sucked out of this piece, and this piece of metal is becoming positively charged. In this solution, we have to have ions dissolved because it needs to be able to conduct electricity so that I have a complete circuit. Let's say that this one is sodium chloride. So I have lots of sodium ions floating around in this solution. However, as the pieces of metal become charged, the sodium has a positive charge. It's going to get attracted to the negatively charged cathode. So the sodium is going to be attracted to this piece. It has a positive charge, and that sodium ion is going to take one of those negative electrons that's extra on this piece of metal, and it is going to reduce it into Na0. So I have Na plus an electron forming Na0 on this piece that has all of those extra electrons that came out of the battery. Since this is reduction taking place, this side would be the cathode. If it's sodium chloride, I also have chloride ions floating around in the solution, but the chloride ions are negative, so they're going to be attracted to the positive anode. Well, the anode is positive, it's lacking electrons, and chlorine has an extra one. So the chlorine is then going to lose its electron and become Cl0. So Cl minus is being oxidized into Cl0 by losing its electron on this side, which is oxidation, which makes this the anode. So the negative side will always have those extra electrons, so something's going to take those electrons, gain electrons from it. So reduction will always occur at the negative end of the battery. So the negative side of the battery will always be my cathode, and the positive side of my battery will always be the anode. The other thing that I can do with an electrolytic cell is electroplate something. So that's using the electric current to coat one metal with another. So this setup here, we have silver, a strip of silver, and a key. The key, it says, is made out of nickel. It doesn't matter what metal makes up that key, as long as it's something that will conduct electricity, I can electroplate whatever metal I want to. So the purpose of this setup is to get silver metal on top of the key. If I look at how this is hooked up, we have the key hooked up to the negative side of the battery. So electrons are flowing through that wire, and the electrons always go out the negative side. So the electrons are going out the negative side of the battery and into the key. which means the key is going to end up, the key is going to end up with a negative charge because it has extra electrons on it. So since the key is negative, it's going to attract the positive ions that are in that solution, and it will reduce onto the key as silver 0. So the silver positive ions get attracted to the key where they gain that extra electron and become silver atoms, which silver doesn't dissolve in water, so it's now attached to the key. We also have electrons flowing into the positive side of the battery. So the electrons are flowing into that, which means they are flowing out of that electrode. So this now has a positive charge on it. Well, because it's losing those electrons, the silver metal that makes up that electrode, it's losing those electrons and it's becoming silver ions, which are dissolving into the silver nitrate solution. So it's losing the electrons to form Ag+, which becomes part of the solution, and an electron which flows into the battery. Notice these two half reactions are exact opposites of each other. There's only one metal involved in the half reactions for electroplating. It doesn't matter what that key is made out of. Also, the purpose of electroplating is to coat the key with silver metal, which means I want the silver ions to turn into silver atoms. That means your key is always going to be where reduction is taking place, so it will always be the cathode. It has to be hooked up to the negative side of the battery. So an electrolytic cell takes an electric energy from a battery to force a chemical reaction to take place. And which side of the battery things are hooked up to is going to determine the direction that electrons are going to flow and what reaction is going to take place at each side. If you were to switch the terminals and hook the key up to the positive terminal and the silver strip up to the negative end of the terminal, what would happen?